Imagine bolting like a literal rocket engine onto a rusty bicycle frame.
Oh, man. Yeah.
Because that is exactly what enterprise IT infrastructure looks like this week. I mean, we are deploying these highly sophisticated autonomous AI agents that can, reason through complex environments and write code.
Right.
But while we're doing that, those same massive organizations are getting compromised because someone left a 5-year-old root password just sitting in a public repository.
It's really the defining architectural tension of our time. You have the absolute bleeding edge of autonomous tooling just crashing headfirst into severely outdated legacy security hygiene.
Exactly. And we're unpacking that exact collision today. Just to give you an idea of how fast this landscape is shifting, we actually used Gemini Notebook to synthesize this absolute flood of public reports, architecture updates, and red team assessments from the last few days.
Right, but we should note, everything we're discussing is grounded entirely in that public source material.
Yes, exactly.
And we should establish up front, the depth of what we are analyzing today is tailored specifically for cloud architects, cybersecurity professionals, and AI and machine learning engineers.
Yeah, we're bypassing the high-level hype today.
Right, we're looking at the actual structural mechanics of these systems.
So to start, we spent a lot of time trying to lock down perimeter access, and I've seen a massive push recently to simplify how we manage resource-based policies, especially at the serverless layer.
Oh, absolutely.
Because managing individual permission statements across, thousands of cloud functions has just been a historical nightmare.
Yeah, it's terrible.
Which is why the recent shift in how AWS handles access is kind of fundamentally altering identity management right now.
Right, you're talking about the new AWS Lambda capability. It now supports complete JSON resource-based policies directly on the functions themselves.
Finally.
Yeah, for years, architects had to manage access by appending single-statement API calls just one by one, which was incredibly fragmented. But now, you can specify multiple principles, actions, and advanced condition blocks, things like Oz principal tag or Oz source vpcemium, in a single, unified document right on the execution layer.
So it's basically shifting from, imperative shell scripts to declarative state for serverless permissions.
Exactly.
And conceptually, having a single policy document makes perimeter checks so much easier to audit.
It does make auditing easier, but the operational danger here lies in infrastructure as code, ISC state management.
Oh, right.
Because when you deploy full JSON policy to Lambda now, it overwrites the existing policy entirely.
I see.
So think about the realities of Terraform or CloudFormation state drift. If your pipeline isn't perfectly synchronized and you push a new policy document, you will instantly strip away unmanaged service-linked permissions.
Wow.
Yeah, you could bring down a critical microservice architecture in milliseconds.
Yeah.
Just because you wiped out the underlying execution rules or added outside of your state file.
Jeez. But I mean, over-engineering our JSON policies in the deployment pipeline doesn't really matter if we're just leaving the root access keys exposed in plain text.
No, it really doesn't.
Because Truffle Security just published an analysis of active public AWS credentials, and the scale of this leakage it's honestly hard to comprehend.
It's staggering.
Yeah, they found over 10,000 publicly exposed credentials, and 88% of them are still active.
Wow.
And 768 of those had full administrative or root access.
And those are concentrated heavily in code hosting platforms, container registries, and quite notably, public AI training data sets.
Right. But the statistic that actually forced me to just stop reading the report and stare at the wall was the timeline. The median age of these active credentials is 5 years.
5 years. Unbelievable.
And furthermore, over 900 of these active accounts had automated quarantine flags that the organizations just simply ignored.
Yeah.
From a purely architectural standpoint, how do passive detection and automated quarantine systems fail so spectacularly for half a decade?
Well, it is a textbook failure of operational reality, just overriding security in tech.
Okay.
Passive detection generates massive volumes of alerts, which, inevitably leads to alert fatigue.
Right.
So when a security operations center sees a flag for a 5-year-old credential, but tearing down that key might break some legacy production system that hasn't been documented since 2021.
They hesitate.
Exactly, they hesitate. They accept the risk rather than cause an outage. So the only structural fix is removing human hesitation entirely.
How do you do that?
You need strict service control policies, SCPs, to disable root credential generation from the absolute start.
Okay.
You need IAM age limits enforced at the platform level and highly aggressive budget alarms. so that if a key is compromised and used to spin up like a massive compute cluster, the account is severed automatically.
That makes sense. And, this isn't just a cloud control plane issue. If we look at hybrid environments and on-premise infrastructure, the lack of identity hygiene is equally devastating.
Oh, for sure.
CISA just released advisory AA26237A, which details a red team assessment of two separate critical infrastructure SOCs.
Right.
Both organizations were fully compromised, but the mechanics of the breaches really reveal a lot about our current defense posture.
Yeah. Organization A failed due to classic operational silos. I mean, they had endpoint detection and response, EDR alerts firing all across the network.
But no one was watching them.
Well, the tools were untuned and completely unmonitored by the identity team.
Yeah.
So the attackers just moved laterally without any real friction.
Wow. But Organization B's scenario is much more alarming to me because they actually did what you're supposed to do.
Right.
They identified the initial access and they rapidly quarantined the compromised endpoints. But despite that isolation, the attackers still took over the domain.
Yeah.
Because they pivoted using default machine account quotas. They abused ESC1 Active Directory Certificate Services templates and exploited unmonitored hybrid Entra ID sync accounts.
Which proves a definitive rule for modern architecture, right?
Yeah.
Endpoint detection is entirely useless without identity hygiene.
Right.
You can isolate a physical host all day long, but if the attacker already holds a golden ticket or a highly privileged synchronized identity, they just bypass the network perimeter completely.
Yeah, they're already in.
Exactly. Architects must immediately set their domain machine account quotas to 0.
Okay.
There is absolutely no reason standard users should have the rights to join new machines to the domain in a modern enterprise.
Yeah.
And additionally, strict conditional access policies for workload identities, they're just no longer optional.
Right. So if identity is failing as a primary perimeter, we usually retreat to network isolation.
Yeah.
But we are now in this weird phase where we're deliberately punching holes in our own zero trust boundaries just to let automated diagnostic tools inside.
Yeah, it's a huge shift.
Like Microsoft's recent general availability announcement for Azure Site Reliability Engineering Agent VNet integration. That's a perfect example.
Well, the intent there is solid. Autonomous diagnostic traffic from the Azure SRE agent now routes directly through your private subnets and your enterprise egress controls.
Right.
So that keeps the diagnostic telemetry off the public internet, and network audit logs apply directly to the automated troubleshooting actions.
I get that. But by removing the external public exposure, aren't you just shifting the risk entirely to your internal network segmentation?
Yep.
Because you're giving an automated, basically a black box diagnostic agent, route access directly into your core workloads.
Precisely. And if that automated agent is ever compromised, or if the underlying language model hallucinates a destructive command during a diagnostic run,
Oh, man.
it becomes the ultimate lateral movement vehicle. I mean, it is operating from inside the house.
That's terrifying.
Yeah, without granular microsegmentation and explicit, tightly scoped RBAC boundaries applied to the agent itself, you're inviting a highly privileged Trojan horse right into your private subnets.
And we are giving these autonomous tools internal access to save time in operations, but we're doing the exact same thing at the architectural planning stage.
Joy.
Google Cloud just integrated AI-assisted quick assessments into their migration center.
Yeah, it's interesting.
It utilizes Gemini to inject VMware exports, like RV tools or cloud billing data, and it instantly generates total cost of ownership models.
Wow.
It automatically maps Gen 4 hardware and hyperdisk storage requirements.
Which, for pre-sales and initial scoping, it compresses what used to take specialized cloud architects months of spreadsheet analysis into literal minutes.
Right.
It's a massive reduction in friction for initial cloud migrations.
The speed is incredible, sure, but
Yeah.
doesn't an AI analyzing a static spreadsheet inherently miss the messy operational reality of how applications actually talk to each other?
Oh, absolutely.
Like, an RV-Tools export doesn't know that a legacy human resources database has a hard-coded sub-millisecond latency requirement with a mainframe sitting in a specific geographic region for data residency compliance, right?
Yeah. You've isolated the exact architectural limitation of these tools. They rely strictly on static inventory data.
Right.
So they completely miss runtime dependencies, latency constraints between microservices, regulatory boundaries. The resulting output is really just a directional screening estimate.
Okay, so it's a starting point.
Yes. The structural danger occurs when leadership sees a highly polished, AI-generated migration plan and assumes it's a deployment-ready architectural blueprint.
Oh, I can see that happening.
It requires rigorous manual technical discovery before committing to any infrastructure cutovers.
Which kind of explains the massive reality check we're seeing across engineering leadership right now.
Yeah.
Looking at the curated analysis from sources like The Pragmatic Engineer, the Enterprise AI Show, Dave Linthicum, and the Tech Report, a clear consensus is emerging.
Definitely.
Organizations are really heavily struggling to reconcile AI hype with actual production utility.
We're seeing the limits of complex multi-agent architectures in the real world. I mean, everyone wanted autonomous frameworks where multiple specialized agents debate and execute tasks.
Right, the dream scenario.
But in practice, those systems are incredibly brittle. We're finding that simpler deterministic data pipelines are significantly outperforming agentic frameworks in enterprise production environments.
And the stakes associated with that brittleness are escalating quickly. I mean, Dave Linthicum's coverage on workers claiming Meta utilized AI to assist in deciding layoffs highlights a monumental issue.
Yeah, that's a huge deal.
When you deploy automated models to execute high-stakes decisions like human resources and terminations, you introduce massive legal, regulatory, and ethical liabilities that most IT architectures are simply not built to govern.
And governing official enterprise-sanctioned AI is proving difficult enough.
Yeah.
The actual nightmare scenario for security architects right now is this shadow AI that employees are utilizing outside of the governed perimeter.
Oh, absolutely. The recent Akamai report on enterprise shadow AI quantifies exactly how bad that leakage is.
It's bad.
47% of enterprise AI interactions are occurring via personal accounts.
Wow.
And more critically, 14.4% of corporate email prompts are being fed into personal freemium AI tiers.
See, this fundamentally breaks traditional data loss prevention strategies.
Right.
Standard corporate identity federation fails completely in this scenario. If an engineer logs into a free public generative AI tool using their personal Gmail account, your corporate audit trails are blind to it.
Right. They can't see it at all.
Yeah, your data retention compliance is instantly voided.
So they're essentially copying proprietary source code, internal architecture diagrams, quarterly financials directly into a public model's training pipeline.
Exactly. Which means relying solely on corporate single sign-on is insufficient. Architects have to mandate group policy objects or browser-level policies to physically restrict unmanaged logins to these generative AI domains on corporate devices. Otherwise, your intellectual property is leaving the perimeter every single hour.
And the models themselves are evolving in ways that make this kind of data leakage permanent. I mean, we are entering the era of persistent memory.
Oh yeah, this is fascinating.
Anthropic is now syncing memory between Claude Chat and Claude Cowork via structured text files. And Microsoft detailed how they're utilizing Azure Cosmos DB lifecycle hooks,
Right.
specifically before run and after run hooks, to distill user profiles and vector facts across sessions for their Foundry agent service.
The mechanism behind this is vital to understand. They are decoupling short-term conversational thread IDs from long-term user memory.
Okay.
When a user submits a prompt, a before-run hook actually queries Cosmos DB, finds the relevant vector embeddings from past interactions, and silently injects them into the prompt before the language model even processes it.
Wow.
Yeah, it's invisible context window padding that solves the classic problem of the AI forgetting previous instructions.
Wait, so if the agent is permanently storing memories of my workspace in a vector database, what happens if I accidentally feed it a corrupted file?
Oh.
Or worse, what if an attacker sends an email with a hidden malicious prompt and the AI ingests it? Does that prompt injection just live in the AI's memory forever?
Yes, and that is a massive structural vulnerability. By moving memory to a persistent database like Cosmos DB, you are shifting the identity and security boundary directly to the application state.
Jeez.
Without incredibly strict database-level identity checks and tenant isolation, you risk severe cross-tenant data leakage.
Right.
I mean, a prompt injection executed today could lay dormant in the vector index, only to hijack a completely unrelated automated administrative task 3 months from now.
That is wild.
Yeah, implementing admin opt-out policies and strict data retention limits within the vector database is absolutely mandatory.
We are essentially giving the AI a subconscious, and now we're giving it administrative rights.
Yeah, pretty much.
Because OpenAI just released an admin plugin for ChatGPT Working Codex. IT teams can manage role-based access control and spending limits directly in the ChatGPT thread using natural language, and it routes the approvals directly to Slack or Teams.
It drastically reduces the friction of context switching for IT operation.
Hmm.
But architecturally, it concentrates an incredibly high privilege operational risk into a single vulnerable chat interface.
Exactly.
Yeah.
When you translate natural language directly into administrative API commands, the attack surface fundamentally changes.
Oh, tired.
An indirect prompt injection could theoretically turn a routine read-only telemetry query into a command that spikes a cloud quota by $1 million or grants unauthorized administrative access to a malicious actor.
You cannot rely on the language model to govern its own output when administrative APIs are involved.
Right.
Immutable audit logs and hard, out-of-band API approval gates are non-negotiable.
Okay.
The system must require cryptographic verification outside of the chat interface before executing any infrastructure changes.
So we have these highly privileged, persistent agents operating on our networks. The final hurdle architects are facing is simply keeping them running without bankrupting the engineering department.
Right, the cost.
Let's look at Google Cloud's new flexible billing for agents. Gemini Enterprise is introducing a pay-as-you-go model with spend-based flexible savings plans offering like 10 to 20% token discounts alongside pooled quotas and hard monthly project spending caps.
The hard caps are specifically designed to prevent bill shock.
Okay.
Because when an autonomous agent gets stuck in a non-deterministic execution loop like trying to solve a coding problem and failing repeatedly, it can burn through massive amounts of compute in minutes.
Wait, so if the project hits that hard spending cap, the billing layer just severs the compute?
Yeah.
How is a platform engineer supposed to build fallback logic for an agent that is mid-thought, it just vaporizes?
That is the exact problem. The risk is abrupt enforcement. If the billing layer cuts off access mid-task, you drop the active agentic state completely. It fails silently. Architects have to build highly complex, custom fallback logic.
Okay.
The system must continuously monitor the quota, and when it nears the limit, trigger a clean handoff to a cheaper model or gracefully save the state to a database before the compute is severed.
The sheer amount of defensive engineering required to keep these tools running safely is staggering.
Oh, it's immense.
And that complexity of resource management extends entirely to the orchestration layer as well. Amazon SageMaker Hyperpod just added native support for Ray on Amazon Elastic Kubernetes service.
Yeah, that's a big update.
Data scientists can now spin up Jupyter Lab environments and attach them directly to active compute clusters with automated node recovery and tiered key value caching.
From a platform engineering perspective, this removes a massive operational burden.
Oh, sure.
It saves teams from having to write incredibly complex custom Kubernetes manifests and dealing with messy kubectl port forwarding setups just to get distributed GPU training running reliably.
It makes access easier, yeah. But what is the actual infrastructure risk of mixing interactive data science tools with managed cluster compute?
Resource starvation. If you have data scientists running interactive ad hoc notebooks on the exact same clusters that are managing long-running Ray compute jobs, you have a scheduling nightmare.
Because they're competing for the same resources.
Exactly. Without incredibly strict IAM task governance and rigid scheduling quotas, a poorly optimized ad hoc query executed in Jupyter Lab could easily starve a multi-million-dollar distributed GPU training job of necessary resources, causing the entire training run to crash.
Oh, man. All of this cloud compute scarcity and orchestration complexity is driving architects to look heavily at local execution.
Right.
But local hardware has historically lacked the memory bandwidth to handle massive local inference. Apple just fundamentally changed that math, though.
They really did.
They launched the 2-nanometer M6 chip featuring dedicated neural accelerators inside each GPU core. Although unified memory on the base chip is capped at 32 gigabytes. But more importantly, they unveiled the M5 Ultra.
The M5 Ultra is an absolute behemoth of an architecture.
Yeah.
It utilizes a quad-I configuration, scaling up to a 36-core CPU, an 80-core GPU, and an astonishing 1.2 terabytes per second of memory bandwidth.
1.2 terabytes per second. I mean, that is built specifically to solve the local LLM inference bottleneck.
Absolute.
But the physics of running that much compute locally cannot be ignored.
No. Sustaining the thermal output for extended local LLM execution on a quad-I M5 Ultra is going to push small chassis desktop cooling to the absolute physical limit.
Right.
Thermal throttling will be the deciding factor in sustained inference performance.
And you have to actually deliver stable power to these devices. The source material included an interesting deep dive into modern fast charging protocols.
Yep.
Fast charging relies on digital handshakes. If you don't have a charger that supports USB Power Delivery 3.0 with Programmable Power Supply or PPS, your 100-watt device might silently drop down to 18 watts because the hardware can't negotiate the voltage.
Which serves as a brilliant microcosm for everything we've discussed regarding enterprise architecture today.
How so?
Well, the underlying hardware is capable of massive, unprecedented throughput. But if the foundational handshake, the baseline protocol, the identity access, the basic security hygiene fails, the high-end hardware is entirely starved of what it needs to function.
That's a great point.
It does not matter how powerful the AI model or the silicon is, if the baseline infrastructure negotiation defaults to a legacy insecure standard.
That is a perfect encapsulation of the architectural reality we are operating in. Well, that brings us to the end of our deep dive today. For more deep dives into cloud, security, and AI insights, make sure you follow the show Cloud and Cybersecurity News on Spotify or Apple Podcasts.
I want to leave you with one final thought to mull over as you audit your own architectures this week.
Okay.
We're currently spending billions of dollars to deploy autonomous AI agents with persistent cross-session memory and the ability to execute administrative API commands via natural language.
Yet, as we saw today with the truffle security data, we still have major enterprises failing to rotate 5-year-old AWS root keys.
Yeah.
So as these two worlds inevitably collide, the first truly catastrophic AI breach won't likely be a sophisticated algorithmic jailbreak.
Yeah.
It will be a highly advanced autonomous agent simply tripping over a legacy default password.
A completely terrifying yet highly probable scenario. Thank you for taking the deep dive with us today. Check your policies, rotate your keys, and we will see you next time.